This is lecture 9 on urban transportation planning. In this lecture we will discuss about trip generation analysis. It would be appropriate to recollect what we did in the previous lecture, so that we get a better connectivity between the portion that we covered and what we are going to discuss in this class. You may recall that we were discussing about the different steps in the systems engineering process in the previous class. To be more specific, we discussed about solution generation phase, solution analysis, evaluation and choice, and implementation in connection with systems engineering process, which are directly applicable for transport system planning process. Then we understood that it is necessary to quantify the inputs and the outputs related to a system more accurately, and more important, to quantify for the horizon year condition. The system inputs are nothing but the quantum of demand for transportation in the future year. System outputs are nothing but the system characteristics that we are planning for meeting the demand in the horizon year. So we need to do a detailed analysis to quantify the input and then to quantify the characteristics of the system that we are proposing. In that regard, we understood that there are 4 important analytical steps followed to get the answer for these questions, namely what would be the total demand in the horizon year, and what will be the characteristics of the system that we propose for the horizon year condition. And these are the analytical steps that we have already seen in the previous class, namely trip generation analysis, captive modal split analysis, choice modal split analysis, trip distribution analysis, and then route assignment by mode. Now in this class we will just hold the first 2 boxes of the flow chart on the left hand side pertaining to base year condition, namely land use survey and travel survey. We will discuss about these 2 aspects a bit later after completing our discussion on all the 4 steps of the analysis. First we will take trip generation analysis. Trip generation analysis means what? Understanding of the trip generated in different land use parcels in an urban area. To define little more precisely, we need to understand what exactly we mean by the term trip. We normally understand the trip as information related to a journey. We ask a friend, how was your trip to Delhi? This means all aspects related to the journey, onward journey, return journey, stay and other related activities. When somebody asks how was your trip to London, implies all aspects related to the whole travel from the point of start to the point of finish of the journey. Whereas here we are going to define the term trip totally differently. This is the definition of the term. A trip for the purpose of analysis is defined as a one-way movement from an origin to a destination. One-way movement from an origin to a destination. To show the same thing pictorially, this is what we mean by a trip. One-way movement of a person from an origin to a destination. What do we mean by origin or destination in connection with trip? Origin could be understood as home, destination as workplace. How exactly we understand these two terms, origin and destination? Any suggestion? For the purpose of analysis, how do we define origin in connection with the trip, and what is the definition of destination?
It's a place origin from where the vehicle starts moving or the person starts.
Yes.
And then the very ends the trip is the destination.
Place where the vehicle starts moving, and then destination is where the vehicle stops. Yes, there is one more answer.
So depending, I mean, based on the discussion we had last time,
Yes,
would it be zone to zone, sir?
that is what exactly is a trip as far as this particular analysis is concerned. We have to remember very carefully, we were talking about the entire urban area to be divided into smaller land use parcels named traffic zones, and then we fix the points of origins as well as destination as zone centroids. These are zone centroids. So, what we mean here by trip is this: movement from one point to another point, from one zone centroid to another zone centroid is a trip, one way movement. This is another trip. This is how we understood, we have to understand trip in this particular context, right. With this understanding, let us proceed further to have more information about trip generation analysis. The principal task of trip generation analysis is to relate the intensity of trip making. What do you understand by intensity of trip making? It is nothing but number of trips made from one point to several other points, to and from land use parcels to measures of the type and intensity of land use. Types of land uses we know in urban areas, their intensity in terms of effectiveness of usage of the different land use types. So, these are to be related. The intensity of travel has to be related to the type and intensity of land use. Let us see how to go about doing this. We need to understand before getting into the analytical aspect that there are two types of trip generation analysis, and these are referred to as number 1 trip production analysis and number 2 trip attraction analysis. Trip production and trip attraction. And the term trip production refers to the trips generated by residential zones, where these trips may be trip origins or trip destinations. Very important point to be understood clearly. So, these are trips associated with residential zones. These could be either trip origins or trip destinations. A trip made from home to work is a home based or trip production, right. A trip made from workplace to home is also a trip production. A trip made from home to school, trip production. School to home, again trip production, because one end of the trip is associated with home. So, that is how we need to understand trip production. Then obviously, trip attraction means trip ends that are neither the starting point or nor the end point are associated with home. They have some other origin and a different destination. This term is used to describe trip generated by activities at the non-home end of trips. Non-home ends could be workplace to shopping area to workplace, or one workplace to another workplace. All these movements are trip attractions. And of course, urban travel demands are made up of a number of different trip types. People make trips for different purposes. So, it is better we classify the trips at least broadly to go further in the analytical process, that have specific spatial and temporal characteristics with respect to the point of origin, point of destination, spread over space, spread over time, right. And the first level of trip classification used normally is a broad grouping into home based trips and non home based trips, and we analyze home based trips separately and non home based trips separately. We cannot combine both these categories of trips and develop models. We need to develop separate trip generation models for home based and non home based trips, because the type of variables that might influence these trips are going to be different, or even if the variable sets are same, the extent of influence of these variables on this trip making might be different. So, we have to have separate models. What are home based trips? Home based trips are those trips that have one trip end at a household, either the origin or destination. Example of non home based trips are trips between workplace and shopping area, business trips between two activity centers. Okay. You may have some correlation between trip production attraction and home based non home based trips, but still we should be able to distinguish between the terms trip production, trip attraction, home based trips and non home based trips. Try to be very clear about the terminologies and related definitions. Since we mentioned about household in connection with home based trips, it is better to understand or define the term household. You may recall that at the initial stages of a discussion, I asked you to assume household to be just family. Now, you will understand that household encompasses different sets of people, including a family. This is the definition of a household. A household is usually a group of persons who normally live together and take their meals from a common kitchen, unless the exigencies of work prevents any of them from doing so. One person of a family may have to leave for work very early in the morning, 5 o'clock, and come home maybe very late, around 11 o'clock. In that case, he or she may not be able to have food from the same kitchen, but still that person can also be considered to be member of the household. That is what is indicated here, but general condition is all should have food from a common kitchen, right. And this is not the end of the definition. Some additional information is also given about households. Persons in household may be related or unrelated to one another or a mix of both. It is a very interesting point. Persons in a household need not be related, right, and they could be just unrelated individuals living together, taking meals from a common kitchen, or a mix of related and unrelated people. So, this is the definition given by the Population Census Department of Government of India, the latest record of 2011. Now, can we think of examples of different types of households? As stated here, a group of unrelated persons who live in an institution and take their meals from a common kitchen is called an institutional household. It is very important to understand the term institutional household, because later we may have to collect data for transportation planning purpose from households. If we understand that households are only people who are living in houses who are mostly related to one another, then we will be missing out other categories of households. So, it is very important we consider the normal households as well as institutional households. Can we think of examples for institutional households? Hostels, all the hostels are institutional households. Rescue homes, ashrams, orphanages, jails, hotels, all are households of institutional category. We should not leave out these kinds of households while collecting data. Now, let us try to reinforce our understanding with regard to home based and non home based trips, as well as the terms trip reduction and trip attraction. What I have shown here are 3 land use parcels or traffic zones numbered as 1, 2 and 3, and letter W stands for workplace. You can see now zone 2 is completely work zone, no other land use activity, it is just a workplace, maybe a factory location or a location with full of institutions and offices. And R stands for residential area. Zone 1 is completely residential zone, there is no other land use activity, whereas zone 3 you can see it is partly residential, and S stands for shopping. So, it is partly residential and partly commercial. This is the reality. You may have mixed land uses in traffic zones, it is unavoidable under Indian conditions particularly. We have developed or we have permitted mixed land use development in most of our cities and towns. Now, let us try to give some nomenclature for the following trips, starting from A and B. Shall we say A and B are home based trips? Why A and B are home based trips? You can see A is emanating from R leading towards W, whereas B is originating at W and destined to R. but we call both these trips as home based trips, right. How do we call the trips C and D? C, D. Any suggestion?
The trips are from a workplace to a shopping place, so they should be non-home based.
Both the trips are non-home based?
Yes sir, both are non-home based.
Why?
Because none of them have residential area as one of the ends.
That is the point. So, in this case we see that C and D are non-home based trips. C emanates from S and it is destined for W, and D emanates from W and ends at S. So, both are non-home based trips. How about E and F? E and F are home based trips, and G, H, G and H are again home based trips. I think now we have very clear understanding about the distinction between home based and non-home based trips. Let us go further to understand the difference between trip production and trip attraction. In this case, a total of 8 trips are shown, is not it? 4 plus 2 plus 2, 8 trips are shown here. A total of 8 trips are involved in this particular case, and if you consider zone 1, 4 trip ends are produced at zone 1. I do not say 4 trips are produced, I say 4 trip ends are produced at zone 1. As far as this analysis is concerned, be concerned with trip ends, not the whole of the trip. Trip ends associated with a particular zone is our concept, right. So, 4 trip ends are produced at zone 1, irrespective of the direction of movement. You just count the number of trip ends connected to that particular zone. If the zone is a residential zone, all are production. So, that is how we say that 4 trip ends are produced at zone 1, right. And how about zone 2? 6 trip ends are attracted to zone 2, because zone 2 is a workplace zone. So, all the trip ends associated with non-home kind of activity is obviously a trip attraction. So, that is how we can say that 6 trip ends are attracted to zone 2. How about zone 3? Yes, please.
Sir, 4 trip zones are produced from zone 3 and 2 trips are attracted to zone 3.
Yeah, it is the other way around. In fact, you must look at the trip ends associated with R. These are productions. How many trip ends are associated with R? Only 2 trip ends are associated with R. That means there are only 2 trip end productions in zone 3, and other 4 trip ends are attached to the part S. So, there are 4 trip end attractions in zone 3. 2 trip ends are produced and 4 trip ends are attracted to zone 3. So, this is how we need to understand the terms home based trips, non-home based trips, trip production and trip attraction. Later on, when we proceed further with the analytical aspects, we should not have any doubt about this basic concept. right. Let us proceed further. The classifications that have been used in major urban transport planning studies for home based trips are as follows. Anybody who can think of the different types of home based trips? What is the basis on which we will be able to classify home based trips? People make trips for different purposes. Obviously, we can classify home based trips based on the purpose for which trips are made. Example is work trips. If they go from home for work, we can call those trips as work trips. Like that, educational trips, trips made to schools and colleges. In fact, in international literature you can find school trips as the equivalent nomenclature. School in their context means both colleges and schools, right from kindergarten to university, right. But we give this nomenclature, educational trips, inclusive of school trips as well as trips made to colleges and universities. And these two trips are more or less mandatory trips. People make these trips on a regular basis. There is no choice, right. People have to go to work on all the working days. Children have to go to school on all working days. Whereas in the case of other categories, for example shopping trips, these trips occur at random. It need not follow a regular pattern. And personal business trips. What is the difference between shopping trip and personal business trip? Yes, please.
Could be like a visit to a bank or any kind of thing related to the running of the household.
Yeah, it is related to running of household, but personal business trips can be related to individuals. As you rightly pointed out, going to bank for some transaction, going to post office, visiting a doctor for consultation, or visiting a beauty parlor for dressing up. All these things are personal business trips. And there could be work related business trips. Consider the sales representatives hopping from one institution to another institutions. Their work is just hopping from one place to another. It is the work related business trip, or some person going from one office to another office for consultation and coming back. All these things are work related business trips. And social and recreational trips. Yes, please.
How come work related business trips are in home based trips?
Yeah, your question is how do we bring in work related business trips as home based trips. Let us consider a sales representative, right. He or she may go from home to a place of work one day to attend to the work. The next day the same person may not go to the same place, but may go to another office or another business place for attending to some other work. So, when the destination is not same for an individual for a particular type of work, then it becomes work related business trip. So, that is how we can include this trip also as one type of home based trip. Okay. But the percentage of this category of trips might be much less compared to the regular work trips and other categories of trips, right. How do we distinguish between social and recreational trips? Can I give examples of social trips?
Meeting friends and relatives can be social trips.
Yes, visiting friends and relatives. So, a typical example of social trips. attending marriage ceremony, things like that, or social trips. Recreational trips, you can imagine all kinds of recreation, and trips made for recreational purpose or recreational trips. Now, my question is, why should we classify home based trips into several categories like this, into 6 different categories? Why not we just treat home based trips together as one category of trip and continue with the modeling process or develop trip reduction equation? Any response? You must think about the causal factors. What are the factors that might influence work trips made by a household, and what are the factors that might influence the number of work trips made by a household and number of educational trips made by a household? Can we say that in both the cases the set of factors are same? The causal factors could be different. If the number of workers in a household is more, then will be more work trips. If number of students in a household are more, there will be more educational trips, isn't it? If there are more youngsters in a family, there will be more educational trips. If there are only elderly people in a family, there could be less of work trips. So, the causal factors are different for different categories of trips, or the influence of these causal factors will not be of same extent for all these categories of trips. Take for example household income. Household income may not influence educational trips significantly compared to its influence on shopping trips, isn't it? We may have variables, but the influence of a same variable on these different categories of trips will be different. So, that is why we need to classify the trips as per the classification shown here, so that our modeling process is more refined and we are able to accurately replicate the reality. That is the purpose of this kind of classification. Now, let us come to modeling trip reduction proper. The process of relating the trips produced by households to the factors influencing trip reduction by appropriate analytical technique is termed as trip reduction modeling. It is very simple to understand. We are trying to relate the number of trips produced to a set of influencing factors, and this process is what we call as trip reduction modeling. The number of trips produced depends on several factors related to the household, because household is the major unit of trip reduction. So, that is how we understand household factors to be influencing trip reduction to a significant extent. Then it is logical to think of the various household factors that might influence trip reduction rate. A large number of transportation studies have shown that the following variables represent the most important household characteristics related to trip reduction. The variables are household size and composition. By household size we mean the number of persons in a household. If it is a normal household, the number of persons are likely to be between say 1 and 6 or 7. If it is institutional household, the number could vary 10, 20 or in hundreds. So, we need to understand the household size in that particular context. And composition of household. What do you understand by composition of household? Household composition. You may have 6 persons in a household. The composition could be different when you consider 2 households of same size, 6 individuals. In one household, if you look at the average age of the household, the average age could be 50. In another household, the average age could be 20, right. The distribution of age of the individuals in a household is very important while understanding the trip production by households. And the distribution of sex of individuals, particularly in developing countries, male female proportion is also another important factor. This is how you need to understand the composition of household as well as the level of education of individuals in a household. If the education level is relatively low, then you can anticipate a relatively lesser trip rate compared to another household with a higher educational level, because their activities will be more or less proportionate to the level of education. We can extend this discussion on various issues related to household composition. These are examples of household composition, right. And number of employees in a household or number of employed persons in a household, very important factor influencing the production. Then number of students in a household, household income, vehicle ownership and so on. Please remember, transport planner has to collect this data from the households. While choosing variables for trip production modeling, you should be aware of the amount of work involved in collecting data as well as the level of accuracy of the database. For example, if you try to collect data about household income, do you think that you will be able to get accurate estimate of household income, even though it is a very important factor influencing the trip production rate? Most cases it may not be possible. Then what do we do? Look for information which are proxies for household income, right. The vehicle ownership obviously under our condition is a very important indicator of household income. Car owning households in India could be considered to be of higher income group, whereas if you look for car ownership as an indicator of income in developed countries, you will be disappointed. You will find that every household is owning a car. As I told you earlier, the car ownership is 500 cars per 1000 population. So, you cannot use car ownership as indicator of income in developed countries, whereas in our country for some more time it is possible to use car ownership as indicator of household income. And when the country develops, you must look for other indicators like the type of dwelling unit in which the household is living, right, in terms of the type of construction and floor space and so on, right, and other accessories they have in the household. So, we cannot collect the household income directly, but we can look for indirect indicators. Now, modeling trip production. in essence involves relating a dependent variable, namely trip production, to a set of independent variables, namely the factors representing household characteristics as we listed, starting from the household size, number of employees, income, and so on. So, essentially we are trying to relate a single dependent variable to a set of independent variables. What kind of analytical technique can be used for this kind of relationship? Any suggestion? The most commonly used analytical technique is regression analysis. The most common analytical tool used for this purpose is regression analysis. Regression analysis will be taught normally in probability and statistics course. It is beyond the scope of this course to go into the detailed statistical aspects of regression analysis. I expect each one of you to develop some background knowledge on regression analysis. It is possible, and still for continuity's sake I will just give a feel of regression analysis by providing basic information about the regression process and the results related to the important steps in the regression analysis. That is what I will do now. Let us take a very simple case of relating one independent variable with a dependent variable, one to one case, trying to relate one independent variable with a dependent variable. Assume that observations of the magnitude of a dependent variable y have been obtained for n magnitudes of an independent variable x, and that an equation of the form ye is equal to a plus bx is to be fitted to the data. Y is the dependent variable and x is the independent variable. We assume in this particular case we have information or data about n values of y, y1, y2, y3 and so on, yn values are known to us. Similarly, the corresponding x values are also known, x1, x2, x3, xn values are known to us, and we are trying to relate y with x using the equation ye to be equal to a plus bx. From the relationship you can understand that we are basically assuming a linear relationship between x and y. It is an equation of a simple straight line. It need not necessarily be linear, but I have taken a very simple example to explain to you the basic concept of regression analysis. The relationship between an independent variable and a dependent variable in reality may or may not be linear. Later we will see what to do if we come across a non-linear relationship between a dependent variable and independent variable. And ye here is nothing but the estimated value of y. Why estimated value of y? This is because of the reason or fact that you will not be able to exactly estimate the value of dependent variable using the regression analysis. There will be some deviation. That is why we just give the notation suffix e for y in the equation. It is always estimated value of y. And a, as you know, is the intercept constant and b is the regression coefficient. Then the above is a basic equation of simple linear regression, basic equation of simple linear regression. For the least squares criterion, the magnitude of B can be calculated as sigma xy divided by sigma x square. Now, you need to know what is least squares criterion. That is the basis for this equation for B. As the name implies, we are looking for the square deviation of the y observations, and then we are trying to fit a straight line in such a way that the sum of the square deviations are minimum. Okay. And let us say we have the x and y values for a particular case, and this is the observed data. We have plotted the observations in the form of a scatter diagram. This is how initially we plot the observed data relating x and y. Our interest is to fit a straight line to represent all these points, or to represent the variation of y based on the value of x. Let us say we try out several possibilities and finally feel that this straight line may give a good fit. This line can be named as a regression line, and this is the equation of the straight line. Because ye is missing here, we must always write the equation as ye to be equal to a plus bx, and this is the intercept on y axis. Let us say the deviation of the actual observed point from the regression line is yd, and deviation of another point which is below the regression line as again yd. We generally name the deviations as yd, but the deviations are in opposite direction. They have positive and negative signs, but we want to ensure while fitting this straight line that the sum of the squared deviations is minimum. That is our objective. If that is minimum, we can say that this straight line represents more effectively all the points that is plotted on this graph, right. That is what is meant by least square criterion. Square all the deviations, sum up, get a number. Do this for various alternative positions of the straight line and choose the straight line which gives you the least value of the sum of the squared deviations. Okay. That is what is meant by least square criterion for fitting a straight line for a plotted data. Okay. Because this is what we call as least square criterion. Then the parameter a can be estimated from the equation a is equal to y bar minus bx bar. Please note here y and x are capital letters, capital Y and capital X, whereas previously the equation for B contains lowercase x and y. They are not same. B is equal to sigma xy divided by sigma x square, and let us get back to this particular aspect. Here small x is equal to x minus x bar and small y is y minus y bar. X bar and y bar or the means of the x and y observations respectively. Or you may wonder, how do we get the equations for b, a and so on? Why should we call x to be x minus x bar, y to be y minus y bar and so on? Please go through any standard probability and statistics book, you will get complete derivation for this kind of regression analysis. That is very important, you have to go through that. You will be taught about regression analysis in your probability and statistics course most probably. It can also be shown that sigma y squared is equal to sigma y d squared plus sigma y e squared, where sigma y squared is nothing but the total sum of squares of the deviations of y observations about the mean value, and sigma y d squared, as we have seen graphically, is a sum of squares of deviations of the y observations from the regression line, and sigma y e squared is equal to the sum of squares of the deviations of the estimated value of y, namely y e, about the mean value, namely regression sum of squares. The residual sum of squares sigma y d squared provides a measure of the variability of y observations about the regression value. That is what we have seen graphically also, and if y d squared is small, then the regression equation may be considered to fit the observed data well. Obviously, if the ratio of the sum of squares explained by the regression to the total sum of squares is known as the coefficient of determination, right. The ratio of the total sum of squares and the ratio of the sum of squares, as explained earlier, is what we call as coefficient of determination, and is usually denoted by the symbol r squared. Some of you would have heard about coefficient of determination. Let us try to understand little more clearly the value of coefficient of determination using this equation. R squared is given as sigma y e squared divided by sigma y squared. This is a very important indicator of effectiveness of regression analysis. Coefficient of determination will indicate the extent of accuracy involved in a regression analysis. To sum up today's discussion, you may recall we first try to define the term trip. Trip is one way movement from an origin to a destination. Then we understood the terms trip production and trip attraction. Then the terms home based trips and non home based trips. Then we were trying to list the factors that might influence the production rate of home based trips, and all the factors are related to household characteristics, because households only mainly produce all the trips. Then while modeling trip production, we understood clearly that it is necessary to classify the home based trips as work trips, educational trips and so on, because the set of variables that might influence these categories or these types of home based trips could be different, and their extent of influence also could be different. Then we found that trip reduction analysis is nothing but relating a dependent variable to a set of independent variables. The dependent variable is nothing but the trip production rate or number of trips produced by a household, and the independent variables are related to household characteristics. The analytical tool used for this analysis is regression analysis. We took up a very simple case of regression of relating one independent variable with the dependent variable, and just try to understand the basic steps involved in the regression analysis, and finally a statistic, namely coefficient of determination, which will give some idea about the effectiveness of the regression process. With this we will complete our discussion for today. We will continue with the rest of it in the next lecture.